Hey, it's just Murray here. I'm going to show you how to do just a basic thing. Now, you should have seen this in class, so you don't really need to watch this video. It's the harder one that you should watch. But this is Red Elk, and he runs off a 3.8 meter tall cliff with a horizontal velocity of 4.2 meters per second and does a face plant in a snowdrift, just like I did so many years ago, right? So let's draw a little picture here. Okay, so here's Red Elk. Running that, we got to give him some antlers. You know, he's going this way at 4.2 meters per second. The cliff is 3.8 meters tall. And he's going to go, he's going to follow that trajectory. Okay? Now, the key on these types of problems is that all that we have to do is to solve two separate problems. We're going to solve a horizontal problem, which is left to right in the x direction, right? And a vertical problem. And vertical is just up and down. Okay? And the good news is we're just going to use the same kinematic quantities that we always use. The displacement, the initial velocity, the final velocity, the acceleration, and the time. It's just that now we've got two problems to solve, a horizontal problem and a vertical problem. Okay? Now, in this problem, we can just sort of look at the numbers. We've got 3.8 meters tall as the cliff. So I'm going to say that our displacement vertically is negative 3.8 meters. We've done problems like that before. Okay? And he's running 4.2 meters per second. That's his horizontal velocity, right? It says it even there, right? So that's the initial horizontal velocity. Now, I'm just going to give you a clue here. In the horizontal direction, assuming Red Elk, assuming that there isn't air friction, assuming that Red Elk hasn't recently eaten at Taco Bell, there's nothing that's going to slow him down, and there's nothing that's going to speed him up in midair. So the final velocity is going to be the same as the initial velocity horizontally, which means that his acceleration is 0 or vice versa. Okay, so horizontally, this is always true. Vertically, the acceleration is just that of gravity, so that's negative 9.8 meters per second squared, right? And this is always true. It is always true that on Earth, anyway, right, these will be the accelerations. Nothing horizontally, negative 9.8 vertically. It's always true then that these guys are the same. And then there's one more thing with this guy. Since that velocity was purely horizontal, that means none of it was vertical. So the initial vertical velocity is 0. Okay? So, and this is true for any, I call these cliff problems. Now, what we're going to do is we're going to solve this thing. And the rules are that we cannot use, if I'm solving, I have to use this side or this side. I cannot use from this side anything from this side, and vice versa. Okay? The only exception to that is time, because the time is on both sides. Yes, it is. Okay, so I'm going to solve, let's solve for this side here. I think I can solve for the final vertical velocity. I'm going to use VF squared equals VI squared plus 2AX. Right, so VF is equal to the square root of, 0 plus 2 times negative 9.8 times negative 3.8. Okay, so let's see, second. I'm hoping you can solve linear kinematics problems. Okay, so 2 times negative 9.8 times negative 3.8. We could leave both those minus signs off. We just can't leave one of them off. Okay, I'm getting 8.63 meters per second. I'm going to say that it's negative 8.63. Remember, it's the absolute value of VF, right? So I'm going to make it negative because I know he's moving downward. Okay. And then I'm going to find the time. I'm going to use x is VIT plus 1/2 AT squared. All right, so negative 3.8 equals, this is of course 0 because the initial velocity is 0, is 1/2 negative 9.8 times t squared. Well, t is just going to be, let's see, negative 3.8 times 2 to get rid of the half, divided by negative 9.8. That's t squared, what's on the calculator, and then I'm going to square root that, so square root of the answer. the time is 0.8806 seconds. Let's just double check that. 2 times 3.8 divided by 9. Yeah, there we go. Okay, so this is 0.8806 seconds, and then I can bring that across, 0.8806 seconds. Okay, and then I'll give you this clue. The only thing we ever do horizontally, the only formula we ever use, is that x is velocity times time, or velocity is x over time, or et cetera, right? It's the first day of class, right? So I'm going to find x. It's simply this time times that velocity. It's always that simple, okay? So that times 4.2 is 3.6986. I'll just say 699 just for fun, meters. So what time is in the air? We'd have to say about 0.88 seconds. How far out does he land? I'd have to say about 3.7 meters out. That's how far out here. Almost as far out as the cliff is high, right? What's his velocity of impact with the snowdrift? Well, this gets a little more complicated, right? Let's take this final velocity right before he hits the snow, right at that instant there. He's moving to the side. He's moving 4.2 meters per second over. And he's moving down 8.63, okay? Well, we know, we're all over this. This is a vector component thing, right? So the velocity of impact as component vectors is 4.2 meters per second x direction plus about negative 8.6 meters per second y direction, okay? If we had to do it as an angle and a magnitude, okay, well, I'm going to find the angle. The angle is inverse tan of 8.63 over 4.2. Okay? So second tan of, whoops, 8. I was doing the wrong thing. I was finding the hypotenuse there. Okay, divided by 4.2. So that angle is 64 degrees, right? So that's 64 degrees. And then let's find the hypotenuse. The hypotenuse is going to be the square root of 4.2 squared plus 8.63 squared. So the square root of 4.2 squared plus 8.63 squared. And that's 9.6 meters per second. Okay? So the velocity of impact, remember velocity is a vector. We can either write it as a component vector, that's kind of cheating, right? Or we can draw a picture of it and say that the magnitude is 9.6 meters per second and the angle here is 64 degrees. Now if they said what's the speed of impact, the speed is not the 4.2 meters per second or the 8.63 meters per second. This is the speed. The speed is the hypotenuse of that. Okay? So step 1, fill in what you know. Step 2, solve. Usually you can find time on one side or the other. When you do, move it across and then solve the rest of it. And then you have to answer questions. That's about as simple as it is.